Antarctica, the coldest, driest, most remote continent. No factories here, only ice, wind, and the promise of discovery awaiting science. Temperatures can plunge below -80°C. Logistics are brutal. Here, nature decides what's possible and what absolutely isn't. The Antarctic Treaty protects this continent for peace and science, restricting industrial development and mineral exploitation across the ice. At Earth's southern end, Antarctica spans nearly 14 million square kilometers, ringed by the Southern Ocean and relentless storms. No smokestacks, no assembly lines. Extreme cold, distance, and strict protections make heavy industry unrealistic across this pristine continent. Summer teams arrive by ship and plane, bringing fuel, food, instruments, everything required to live and work in isolation. Research stations are the hubs, modular, elevated buildings engineered to shrug off drifting snow, fierce winds, and deep cold. Each station runs like a tiny city. Power, heat, water, food, and communications monitored with precision, 24 hours a day. Diesel generators remain essential, backed by wind turbines and solar arrays that harvest the long polar sun through summer months. Potable water begins as ice. Stations melt, filter, and carefully recycle every drop to protect Antarctica's fragile environment for generations. Food arrives in bulk. Kitchens plan months ahead to feed crews through storms, delays, and the long polar night. Insulated quarters turn steel boxes into homes, quiet bunks, warm lounges, and windows opening onto endless white horizons. Field teams load sleds, fuel, and instruments, check radios and routes, then head onto the ice for days of work. Ice cores lift cylinders of frozen time, preserving trapped air bubbles that record ancient atmospheres and climate swings. In the lab, layers and gases become data, temperature histories, greenhouse levels, and signals from distant volcanic eruptions. Clear, dry air benefits astronomy and space weather work, as observatories monitor stars, auroras, and cosmic particles above the ice. Automatic stations track wind, temperature, humidity, and radiation, streaming continuous measurements across the polar plateau to inform forecasts worldwide. Drones and radar map crevasses and ice flow, improving safety, guiding routes, and revealing how glaciers move beneath us. Biologists tag penguins to track migrations and breeding, measuring the Southern Ocean's health through their lives with careful protocols. Seals rest and breed on sea ice, their behavior reflecting shifting ecosystems and changes in ocean conditions over time. Icebreakers and cargo ships push through pack ice, delivering fuel, food, and scientific equipment to coastal bases each season. Nothing is left behind. Waste is sorted, stored, and shipped off the continent to protect Antarctica's pristine environment. When whiteouts strike, crews rope between buildings, navigate by flags, and shelter until visibility returns. Safety over speed, always. Stations drill for medical and fire emergencies. In a deep cold, seconds matter, and preparation saves lives again and again. A 3D printer turns spools of plastic into brackets and gears when resupply is weeks away across the ice. Wind carves sastrugi, hard ridges across snow, rough on skis and treads, reshaping surfaces daily under relentless polar gusts. Flag lines mark routes between buildings. When visibility drops, these simple markers guide everyone safely home through snow and darkness. Heavy tracked crawlers haul fuel and cargo across the plateau, slow, loud, and unstoppable over frozen miles. Every liter of fuel is managed carefully. Double-walled tanks, drip trays, and strict procedures to prevent spills in this fragile place. Cold, dense air pours downhill as katabatic winds, powerful, relentless flows that scour snow and test structures day after day. A snow-capped volcano vents thin steam into polar skies, reminding us fire sleeps quietly beneath the ice. Teams drill through sea ice to measure thickness and salinity, tracking seasonal change along the frozen coast. An under-ice robot scans dark waters, mapping habitats and undershelf caverns no human divers can safely reach. Divers descend through a cut ice portal, tethered and timed, collecting samples under strict, rehearsed safety protocols. Winds sweep snow from blue ice fields, exposing dark meteorites, space rocks waiting for gloved hands to collect and catalog. A small greenhouse under LEDs grows crisp greens, salads and herbs that lift morale during long polar months. As summer ends, crews depart. A smaller winter team remains, facing months of darkness and isolation with careful routine. Satellite windows are short. When a pass opens, the station sprints to upload and download essential data before the signal fades. When bandwidth fails, hard drives travel home by ship or plane, carrying months of precious research data safely, layer by layer. Base, mid, shell, goggles, mitts. Skin exposure here is measured in seconds, not minutes. Batteries, seals, and lubricants are tested for deep cold performance. Some chemistries fail quickly, others barely survive. Elevated modules shed drifting snow. Jack systems lift structures when drifts grow, keeping doors and windows clear year-round. Snow groomers compact skyways so aircraft can land safely, even after storms reshape the surface overnight. Helicopters deliver sling loads to remote sites when ground travel is impossible, placing cargo precisely and quickly. Teams practice crevasse rescue, anchors, pulleys, rope systems, because knowing is survival when real emergencies arrive. A portable camp unfolds fast. Tent, stove, comms, medical kit, everything required to survive a sudden night on open ice. Geodesy crews bolt GPS stations to bedrock, measuring ice motion millimeter by millimeter across seasons. UV spectrometers scan the sky, tracking ozone levels and the slow healing of the seasonal ozone hole. Arrays read charged particles and auroras, observing how space weather ripples through Earth's polar atmosphere. The final summer flight lifts off. Winter crew watches taillights fade into darkness, knowing isolation begins. Scientists cut a clean snow pit, reading layers and measuring albedo, the brightness that controls melt and energy exchange. A net radiometer tracks sunlight in and heat out, numbers that feed climate models and forecast surface change. Rows of snow stakes reveal accumulation and scouring, logged patiently month after month. Shallow cores show snow compressing into firn, the step towards solid glacial ice. A radiosonde balloon rises skyward, streaming wind, pressure, temperature, and humidity from surface to stratosphere. Ice crystals bend light into a glowing halo, and bright sundogs, polar optics shining in freezing air. During polar night, stars bloom and auroras dance. Time-lapse reveals a living sky above the silent station. Wind steals heat fast. At -40 with wind, frostbite can arrive in minutes, sometimes seconds, without protection. A thermal camera shows where warmth leaks from buildings. Fix the gaps, save fuel, and survive winter more efficiently together. Sled-mounted radar maps hidden crevasses and layers, keeping routes safe and revealing the glacier's internal structure beneath our feet. Jets of hot water melt boreholes through ice shelves, allowing sensors and cameras to explore the ocean below safely. A CTD rosette dips beside the ice edge, measuring temperature and salt from surface to deep, dark layers. An autonomous vehicle glides beneath the shelf, mapping caverns, currents, and melt rates where ice meets ocean. Sterile drilling taps a lake beneath the ice. Samples remain pristine to avoid contamination and protect ecosystems. Antarctic krill swarms shimmer underwater. Tiny crustaceans feeding penguins, seals, and whales, supporting vast food webs. Penguins rocket through water, proposing to breathe, hunting with precision along the edge of the pack ice. Biologists attach a temporary suction cup tag, a few minutes of handling for months of movement and dive data. A tiny logger on a seal records dives and temperature, turning animals into quiet partners for oceanography. Drones count colonies from altitude, minimizing disturbance while gathering accurate numbers for wildlife management across remote coasts. Inside the station, server racks hum as sensors stream into databases. Backups guard every byte against outages and storms. Doctors consult by satellite link, guiding ultrasounds and care from clinics thousands of kilometers away. Midwinter brings a rare feast, music, and messages that lift spirits and bind the winter crew through darkness. Postcards stamped at the bottom of the world carry memories from Antarctica to families and friends across oceans. Skuas, bold and curious seabirds, circle the station, scavenging opportunities near field camps. In emergencies, teams carve a snow trench and wind wall, cold, cramped but life-saving when storms explode across the plateau. Waves knead grease ice into circular pancakes that collide, raft together, and freeze during early winter along the coast. Tides and wind shove floes together, buckling sea ice into jagged pressure ridges, travel hazards and habitats for life. Delicate frost flowers sprout on new ice, releasing sea salt aerosols that influence clouds and chemistry. Diamond dust fills ultra-cold air. Ice crystals lift station lights into shimmering vertical pillars. Nacreous clouds glow like the mother of pearl, forming in the frigid stratosphere and linked to ozone chemistry. Warm, dry foam winds spill off mountains, melting snow into fast rivulets along the Antarctic peninsula. Persistent winds open polynyas, patches of open water that fuel life and shape sea ice formation near coasts. On wind-polished blue ice, a natural runway appears. Hard, smooth, carefully groomed for safe landings. When satellites fade, HF radios carry voices by skywave, a lifeline during storms and darkness. A protected clean air sector keeps instruments upwind. No vehicles, no smoke, ensuring pure atmospheric samples for long-term records. Filters and optical counters capture aerosols, sea salt, dust, even microbes, the tiny travelers of polar air. Laser and UV analyzers track carbon dioxide and ozone, reading changes in Earth's breath above the ice. Stable water isotopes, oxygen-18 and deuterium, reveal past temperatures and storm tracks locked inside snow. Across a snowy field, geophones and controlled thumps map bedrock depth, imaging valleys and ridges buried beneath kilometers of ice. From those echoes, 3D maps emerge, semi-transparent ice above colored terrain, revealing hidden mountains, valleys, and basins. Sensors and cameras watch ice shelf rifts widen, providing early warnings before dramatic calving events. Every shift begins with a safety brief: routes, radios, frostbite checks. Discipline and planning save lives. Fuel is warmed and filtered to strip ice crystals and water. Engines demand clean, dry fuel in Antarctica. Coastal bases turn seawater into drinking water with reverse osmosis. Pre-treatment first, membranes next, quality control always. In deep freezers at -50, boxed ice cores wait, decades of climate preserved for future studies. Buried detectors watch for neutrinos, ghostly particles passing through Earth, signals faint, cosmic, and rare. Teams turn measurements into models, forecasting ice flow, sea level, and weather as the climate warms. International crews share camps, data, and skills. Science without borders on the white continent, building trust and results through collaboration. The message is clear: protect the cold, cut emissions, and let evidence lead. Antarctica has no factories, only the factories of knowledge inside its research stations. In this frozen laboratory, science powers discovery and cooperation protects a continent. The lessons we learn here ripple across the planet. Enjoyed this journey across the ice? Like the video, share it with friends, and subscribe for more science stories soon.